am Shakti Devi, lecturer, Department of Electronics, Sita Lakshmi Ramasamy College, Trichy. Now we discuss the topic Basics of Control System. What is control system? Control system is almost a collection of electronic or mechanical devices used to manage and regulate the behavior of other devices or systems. It is often computerized. The simplest example of the control system is to control the temperature of a room. The working principle of the control system is input, process, output, cycle. This is used to achieve the desired output. The various fields used in the control system are electronics, automation, engineering, and robotics. Examples of the control system are thermostat in heating systems, cruise control in cars, robotics, and industrial automation. Next one is the components of the control system. The main components of the control system are sensor, controller, actuator. Sensor. Sensor is used to get the input of the control system. It detects the physical quantities like pressure, temperature, position, etc. Sensor converts its input into electrical signals. This electrical signals is given to the input of the controller. Next one is the controller. Controller is used to produce the control signals. According to this control signals, the desired output is achieved using the actuator. Controller receives the signal from sensor and the control signals is sent to the actuator. Actuator carry out the necessary action to adjust the system output and converts its energy into physical motion to control the component in a control system. Examples are motors, valves and relays. Next one is the classification of control system. Control system is classified according to the parameters used in the system. The parameters are type of signal, type of loop, type of system and number of input and outputs are used in the system. According to the type of signal, the control system is classified into continuous time control system and discrete time control system. In continuous time control system, all signals are continuous in time and discrete time control systems, one or more signals are discrete with respect to time, type of the system. If the system is linear, then the output is proportional to the input. That type of control system is called linear control system. In non-linear control system, the output is not proportional to the input. Next one is number of inputs and output used. Based on this, the control system are classified single input, single output control system and multiple input and multiple output control system. In SISO, a system having only one input and one output. A system with multiple inputs and multiple outputs are called MIMO. According to the type of loops used, the control systems are classified open loop system and closed loop system. Open loop system does not affect the control action. In closed loop system, the output is fed back to the input. Next one, we discuss the open loop control system. In open loop control system, the output is not fed back to the input. The block diagram of the open loop control system is shown in figure. The control action is independent of the desired output. Examples of the open loop control system are automatic door openers, digital alarm clocks, electric kettles, bread toasters, electric clothes dryers are examples of the open loop control system. Closed loop control system. The block diagram of the closed loop control system is shown in figure. From this figure, the output is fed to the input. It uses mechanical or electronic devices. It automatically regulates the desired output without human interaction. Most modern closed-loop systems are electronically controlled. Next one is a mathematical model of the control system. Mathematical model is a process used to represent the system using mathematical equations. Using these mathematical equations, various analytical and computational techniques may be used for analysis and synthesis purposes of the control system. The system under considerations are dynamic in nature, so the equations are usually differential equations. Mathematical model is used to design the control system and optimize the system performance. The commonly used mathematical models are differential equation model. This is used in time domain, and transfer function model. This is used in S domain, and state space model. This is used in time domain. The various mathematical tools used in the control systems are linear algebra, statistical models, computational methods, Laplace transform, frequency response, feedback control. Uses of the model depends upon the application. For example, to find the transient response or steady state response, transfer function model is very useful. For optimal control of the application, state space model is used. Next one is the control action. Controller produces a control signal to adjust the system output. Using these control signals, the control action is taken by the actuator. 6 basic control actions are very common among industrial analog controllers. The control actions are on-off control action, proportional control action, integral control action, proportional plus integral control action, proportional plus derivative control action, proportional plus integral plus derivative control actions. Next one is the test signal. Knowledge of the input signal to control system is required to predict the response of the system. The characteristics of the actual input signal to the control systems are a sudden shock, a sudden change, a constant velocity, a constant acceleration. The test signals resemble these characteristics are used to predict the system performance. The commonly used test input signals are impulse signals, step, ramp, acceleration, and sinusoidal signals. The standard test signals used for testing the control systems are step signal, unit step signal, ramp signal and unit ramp signal, parabolic signal and unit parabolic signal, impulse signal and sinusoidal signal. Advantages of control systems. Capability to respond something faster than humans, and it is very reliable, precision and accuracy. Efficiency in operation. Automation reduces human efforts. Enhanced safety in complex systems. Controlled and monitored remotely, including space science and remote infrastructure. Adaptable in any conditions and in any requirements. Can be reprogrammed to accommodate different operating functions. Challenges in control systems. System stability, complexity in design for large systems, sensitivity to external disturbances, maintenance and cost considerations, need high specialized knowledge, so complex to operate and handle, highly depend on electricity in case of power failure. Thank you for your watching. Thank you.